Hello, my name is Minh Nguyen from Auckland University of Technology, AUT. So today I will present a project called Temporal color-coded facial expression recognition using convolutional neural network. Okay, to start, I will talk about the research background and the significance of the research. So we live in New Zealand, and this country has one of the highest teenager suicide rate in the developed world. So normally if a person had a mental health problem, they are likely to think of committing suicide. And the mental health issue is actually now a hot topic over many countries, not only in New Zealand. It's related to so many stuff like poverty, domestic violence, drug or alcohol abuse, or despair. And especially with this COVID pandemic, it just makes things worse all over the world. So at the present, the key to check for the suicide rate is to rely on the people's mental health risk assessment, like they go to the hospital or consultant to check for their mental health issue because they feel very depressed. Nowadays, deep learning methods have achieved quite a good facial micro expressions recognition via camera or CCTV. So for example, they can actually recognize the happiness moment, like smiling detections, crying detections, anger, fears, sadness, surprise, or something like that, based on the look of the pictures, like what you see on the right hand side. So now it related and it leads to one of our questions is, can we build an AI device that help efficiently detect depressions by just looking at the presence of a number of negative facial expressions? Like for a long time, if we detect and see a lot of fear or sadness or anger over the face of people, it could be a indication of depressions, and we will need to do something with that. So we are looking at building an IoT device for kind of a anger management. So as I already stated, the goal is to build a anger management IoT device so that it can help identify the vulnerable populations, and it could help the country, government, or the managers to provide counseling work to employees and people living around. So what is the challenge here? The challenge is AI nowadays can easily detect human facial micro expressions like smiling, but it only happens in one frame of the video. Say like the video can be like 30 frames a second, and also it's usually ambiguous and return with various uncertainty. For example, the face could be 45% happy, 23% surprised, and 3% sad. So it is a number of uncertainty coming in, and also it's extremely tough to identify and verify the emotions of somebody in, say, a long-term period, like the last few minutes, hours, days, weeks, or months. So as I say, the depression only come after a very long time of sadness rather than just 1 or 2 hours of sadness, it will not create depressions. So we will build an idea for an anger management IoT device that could help reduce the depressions, stress levels, and the suicide rate. And with this research device will help create a more healthy working, teaching, learning environment. Like we can put that IoT device inside a classroom, an office, or a household table, dining room, or something like that, so that it can access the depression level of an detecting environment, like to see if the household is healthy or not. So the unique method, this is quite a little bit unique. So we propose to make use of the 3 primary color, red, blue, green, and their blending color like yellow, cyan, magenta, and white to present the 7 emotions that we detected, just like the same way that lights are blended together, as you see. So the 7 emotions are anger, disgust, fear, joy, sadness, surprise, and neutral. So the first step we will need to use for that to classify these emotions. So in the vein of CNNs, we will need to construct the emotional expression data set for that 7 classes of the micro emotions classifications. So this is exactly what we're gonna do. Whenever we detect an emotion, one of the 7, we will record it as a color. So this can be a dot rather than text, so a color on top of a 2D image. The color dot will have different radius to make a big dot or small dot, just like a raindrop. So the more certainty, the higher certainty of the emotions will get a bigger dot. A smaller certainty, it will get smaller dot. So actually in one emotion, in one frame of one face, we can have as many as 7 dots that drop down onto the white canvas, and that white canvas will at any moment will be used to detect the emotions overall of a frame. Okay, so it's just like a 2D color, and the temporal emotions will be collected just like a movie. So a movie of 2 hours, 2 minutes, or even 2 weeks, 2 months, and so on. So the way we do that is to eliminate the effect of storing all the historical data in text or in database. The emotion detected too much long time ago may be filled away by other more recent ones. So for example, like emotions of 2 months ago might not strongly affect today feeling. So the more recent one will be will affect the current feeling stronger. So the right figures display 2 emotional canvas that created from say 2 video sequences, one with lot of sadness moments and the other with lots of laughter. So as you see on the left hand side of the figure, a majority of the blue dots is appearing on the sadness samples, and the happy ones contain a lot more green and green drops. Okay, is to indicate a sad movie and a happy movie. Here is a quick talk about the implementations. In order to implement that, we will have to follow a number of steps. First of all, we will collect the expression database, apply the image pre-processing to augment data, include image resizing and noise removal, apply reliable face detections, train the model and deploy it for emotion analysis and analytics, so that at the end we will achieve temporarily based color-coded facial micro-expression recognition with the number of color as shown on the right-hand side. And we can collect at every moment the graph of the trend for emotions of the past and the present state. So at every moment we might see a graph of trends similar to what you see on the right hand side here. And based on that trend, maybe we can actually predict the future state, and if it will reach a threshold, it might be vulnerable for people to get deeply depressed. At this stage, we have started to build a proof of concept of the device. We have the model trained using the dataset, which is collected from different sources, and we have to set a 7 target emotions, as I already talked about: joy, sadness, anger, surprise, and so on. Two of the video that demonstrate the situations. So this is one of the happy video, and you may see that I will fast forward a little bit. Whenever a person or the face of the people are detected with a smiling, then a green dot will be dropped on top of the canvas, and whenever a sad face is detected, a blue dot will be placed on top of the canvas, and so on. So after a while you might be able to see that this is a very happy video, and you may see in the bottom the light is green, is placed way higher compared to the blue light and the red light. In contrast, I also display another footage holding quite a lot of sad moments. So you might see here, whenever a sad or angry face is detected, then a red and blue dot will be shown, and then after a while you might see that the red line and the blue line is placed on top of the green line. So this is quite a sad video. So now we will, with the proof of concept, the kind of software side is done. So the next goal is to produce a design of a depression anger management IoT device that could be equipped, as I say, in household, office, school, and beyond. So we have drawn down a design with a small PC desktop kit on the bottom. It's connected with one or two 360 cameras, so that they can have a surrounding image of the entire environment, and on top of that will be the emotion LED light. That LED light can display all the color, and the color will show the current and the long-term emotions of the environment, detecting environment. So this figure show the device that we plan to build in the future, and we actually have tested that on the 360-degree camera over here. The result is fairly good. In order to make it work, then we have draft a research methodology of design science for the entire project, and you can quickly see down here. So the research impact of this project is a depression angle IoT device, angle management IoT device that can lead to a exciting commercial product. It can emit LED light to alert people about their emotions, expressions. It might work just like a slow down speed sign to warn people to get their anger under control and express their feelings in the healthier ways. So just like what you see on here is like the traffic light to say that you are, or the environment or the working environment is reaching to the boundary line. So there are several research impact we might get out. Removable IoT device. The device could help to reduce the depressions, stress levels, suicide rate in New Zealand and other countries. And the research helped create a healthy and harmonic workplace environment for employees, students, and many more. That concludes my presentation for this. And if you have any questions or if you want to have some collaboration requests, please feel free to contact me.